So here's an example of a homogeneous differential equation. Say you have 3x minus 5y over 5x plus 2y. And let's also assume that y of 0 is 2. Let's try to solve this differential equation. Yes?
What is this an example of?
Homogeneous differential. So first check that the top is a homogeneous polynomial because it's order 1, order 1. The bottom one is also homogeneous polynomial because it's order 1, order 1. So if you moved it over here, you'll have a homogeneous polynomial times y prime equals another homogeneous polynomial. And I told you that in this case, you definitely have a homogeneous differential equation. Although to make sure that you do have such a thing, you would divide both top and bottom by x, so that the right side is a function of y over x only. Whenever, in other words, if you divide by x, you're going to get y over x, y over x. So whenever y appears, you would have it attached to over x. Okay, y over x will always appear together on the right side if you change it into that format. Okay. So in those cases, we do a change of variable. Y equals to x times u, which is really saying I want u to equal to y over x. That's what it's saying, right? Which will give you, according to the product rule, the derivative of this is xu prime plus 1 times u. Okay. I'm using the product rule. You differentiate the product, differentiate the second one, leave the first, differentiate the first one, leave the second. Okay. And using these, I can rewrite the entire differential equation in the following format. Xu prime plus u will replace y prime, right? That's what we figured out. On the right side, 3x is okay, but whenever you see the y there, you're going to replace it by xu. 5x plus 2xu. And I guess since top and bottom are both divisible by x, you can divide by the x's top and bottom, and you get 3 minus 5u equals to 5 plus 2u. Now let's put the u to the other side, and you get xu prime equals to 3 minus 5u over 5 plus 2u minus u. So what I did was this u is moved to the other side to get you this. And then I'm going to put it into single fraction. In order to do that, I need to put common denominators. So I'll put the common denominator once. 3 minus 5u is from the first fraction, but think about u as u over 1. If you multiply 5 plus 2u top and bottom, then in the second fraction, the top will be 5 plus 2u multiplied to u, which is equal to, well, let me write it again, xu prime, which is equal to, let's see, negative u times 2u will be negative 2u squared. Negative u times 5 minus 5u will be negative 10u. And then 3 plus 3 is what you get here. And for this, you have 5 plus 2u.
I have a question.
Yes.
maybe I'm just not seeing it, but you're multiplying by 5 plus 2u. Or is it on the top?
Oh, yeah, yeah. So I'm multiplying 5 plus 2u, both top and bottom, so that these two will be common. Once you have the common denominator, I can put them together. So this is what you do. Okay, I want to rewrite u prime as actually du dx, because I see that this is a function of u and that's a function of x. So that means it's a separable equation. You can separate the x and y. And because du is here and dx I can move it to the other side, I see that the format you want it to be in is move this to the other side so that this gets divided. So you have negative 2u squared minus 10u plus 3. And because this flips, you get 2u plus 5 du. And if dx goes to this side and x goes to the other side, that they also get flipped. So x becomes 1 over x, and dx, instead of being in the denominator, becomes on the top. You see how I'm dividing by this, dividing by that, dividing by that. Okay. Now you integrate both sides. Now I've been talking about this handy formula which says f prime over f dx is ln of the denominator plus c. And let's just hope that it does work in this case. So if you differentiate this, what do you get? You get negative 4u minus 10. Initially, it looks like negative 4u minus 10 doesn't do much, but it's actually, if you multiply negative 2 to top, this top also becomes negative 4u minus 10, which is exactly the derivative of this, right? So if you want this left side to look like f prime over f, what should you do?
Times the numerator by 2, and then the whole
Times
integral,
the numerator by negative 2,
and then the whole integral by 1/2.
and then you divide it by
Negative
negative 2. Okay? So that's
Negative
what
2?
you, yeah, negative 2. You have to undo what you did, right? So let me erase this part.
Wait, divide or multiply the whole integral?
Either multiply by negative 1/2 or divide by negative 2. It's the same thing, right? So here's what I want to do. I want to multiply negative 2 to the top so that I get negative 4u minus 10 over negative 2u squared minus 10u plus 3 du. But negative 2 can't just appear out of nowhere, right? If I created it out of nowhere, then I should also destroy it so that it's same as what I had before, right? So you want to destroy that by dividing by negative 2 or multiplying by negative 1. Okay? So if you're curious why these two are the same, just multiply negative 1/2 to the top and you'll see it's exactly the same thing as that one. Okay? So I just rewrote the left side into this format, and on the right side this is just ln of x. The integral is ln of x. And I get negative 1/2 ln of the denominator. I'm using that formula. Equal to ln of x. And, oh, I have to put plus c somewhere. I forgot to put plus c. You have to put plus c only on one side. And then you multiply by negative 2, you get ln. let's multiply by negative 2, so I get negative 2 ln of x. I should really be writing negative 2c, but that's just another constant. Now what do? I want to get rid of the ln by doing this. And it's, okay, first of all, this cancels. No problem. But what about this?
Nope. The 2 hops over the log. Becomes the exponent.
Yeah, you have to make this negative 2 hop over the log like a frog. Right? So it jumps over the log. And if you do that, then it becomes e to the ln of x to the negative 2. And then instead of plus c, I can also write e to the c here. Right? So I made this plus into product of two things. And I also made the negative 2 jump over the log. So now that there's nothing in between e and ln, so they can cancel each other. And e to c, I can redefine this as a c tilde or something. So I can rewrite this as x to negative 2 c tilde, or just write it as c.
The c is multiplying then?
No, I'm just redefining e to c as a c tilde. But this is just a constant. It never changes. It doesn't depend on x, right? This is also a constant. So at the end of the day, you can just remove the tilde and say just whatever constant it is, it should satisfy. So we're almost there. See, I have this equal to that. But remember, what was u? Y was what? I erased it,
Y
but
is equal to xu, so
y was equal to xu, so u is
y over x.
u is y over x. Okay. So you have to replace that. So you have negative 2 y squared over x squared minus 10 y over x plus 3 equal to some c tilde. X to the negative 2 is same as x over x squared, right? And then I guess we can multiply by x squared to get rid of all the denominators, and you just get purely non-fraction. So negative 2y squared, and then negative 10xy plus 3x squared equal to c tilde. So that's what you get for y. At this point, you really, I guess you can use the quadratic formula to solve this for y, but it's just messy. So just leave it like that. Sometimes when you solve a differential equation, if you see that y is not by itself, and it's complicated to solve for y, you can just leave it like that. All right, so this is our answer for the time being. However, this doesn't satisfy every requirement that we imposed originally. What does it not satisfy?
Y 0.
Y of 0, right? Y of 0 should be 2. So how do we interpret this? We didn't make this satisfy, so what does this really mean? See, what's plugged into y? X. X goes into y, so this really means when x is equal to 0, y is 2. So when x is 0, y has to be 2. That is going to determine the value of c tilde. So let's do that. When x is 0, so if I plug in 0 here and 0 there, so I get, then y has to be 2. So negative 2 squared minus 0 plus 0 is c tilde. So c tilde must be negative 8, because negative 2 times 2 squared, that's 4. 4 times negative 2 is negative 8. And therefore, our final answer, I want to put it up here. The final answer is negative 2y squared minus 10xy plus 3y squared equals to negative 8. Okay, depending on the method you use, you could also multiply by negative, and you can get another equivalent. Oh, that's x squared. Sorry. You could get another equivalent solution that's like 2y squared plus 10xy minus 3x squared plus 8. That could be another answer. All right. Do you have any questions?